In today's video, I will teach you what is inside this 25 watt LED lamp. Now show the table. prcnrgy 25 watt 6500 K bulb. This is a 25 watt LED bulb which is on 220 volt AC input, and this is a 25 watt LED bulb. Now open. It is a fused one. So what we tend to do, we need a screwdriver, flathead one, and carefully place over here or anywhere in the screen and place a thumb it, because in proper way bulb opening, LED bulb opening, we first make sure this is not made of glass, it is made of plastic, this fusible plastic, and then you take a flathead screwdriver and put in air and put in with thumb to press a little bit, because it won't slip out. If accidentally slip out, it can injure your hand. So always place a thumb little bit to cover the sharp tip of the bulb in order to accidentally slip them, in order to prevent your fingers to damage, and bulb come out like that. There are 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 28 LEDs, 2 in parallel, 2 in parallel, 2 in parallel, and 14 in series, and these are driver circuit. So I also see there are twice of LEDs burn like these, and these. So there are total 9 LEDs. I will doubt these LEDs are burning, so maybe I can repair this or check this. And there's a button regulator. Open these screws in order to remove them, but this time this is a step down button converter. To step down, input 220 volt AC to any certain DC voltage according to this LED chip, and this LED chip contain 28 LEDs, and which stays in a 14 LEDs is connected in series. So maybe there are 30-40 volts here. Now it's not easily come out. Although I not use mic, I am also making a video in the roof, so there may a little bit noise, maybe tummy, which is not a big problem. There are metal sleeve here, which sleeve holds this. It is a metal heat sink which can hold the main base of the bulb, and also it's fitted with this LED chip. So this LED chip is soldered into the driver circuit. So if I cannot remove directly with removing this heat sink, so this heat sink is very tightly placed in the metal shielding. That's why I pause them, then I open it, and then I continue the video once first. So here's the bulb bottom side. Now it's totally open, and now it's inside the circuit board. There's a fuse, a resistor, transfer capacitor, diode, some turn resistance resistor, and driver IC power capacitor, and output capacitor, and there's a coil, inductor coil, and there is some feedback resistance, and there is a back side, and there is LEDs. Now I already completed the reverse engineered. Now see how it's worked. This is the reverse engineering. Live dose 2.2 ohm, 5% tolerance resistor. Google goes directly with the last wire capacitor, and then those rectifier made an M7 4H diodes, and then it's out those to the capacitor negative, as well as 2.2 ohm 3 resistors in parallel to ICP number 7. This is resistance 7 sensing resistor. So 2 in parallel, 3 resistors parallel, each resistor 2 ohm, 500 milliohms from here. And ICP number 1 is also negative. ICP number 3 is also negative. Pin number 2 to the ICP number 2 to the negative terminal. They are connected to the 20 ohm resistor for IC internal feedback, and positive dose directly to a rectifier positive to a capacitor positive, and then those and once and this IC drain pin and pin number 6 and pin number 5 is drain, which that and the total oil 4.7 microfarad 450 watt capacity connected and also connected at 15 kilometers, one under 50 kilometers in parallel. And I6 is switched pin number 6 or pin number 5 to a coil and coil to the resistor. So coil as magnetizing. When coil is demagnetized, it goes a diode with our charge 4.7 microfarad, 450 watt capacity, and then goes output. And these I finished 240 kilo resistor in voltage divider, which is connected to output negative. Input negative this capacitor of is 2.2 microfarad pillar in a voltage divider adds the smooth of this IC power. Once this IC is on, IC is on and IC draws power, and if power is fluctuating, this is smooth the power.